Hello, everyone. Let me just make sure I'm coming through okay. I think I am. Yeah, hello, everyone. Good. So yeah, we're on at a really unusual time. I guess we can call it the Australian special or something. For some of you, I'm seeing times being put in chat. Some of you, it's a reasonable time of day. It's not for me. It's about 2 o'clock in the morning, but hey, you know, I said these streams would be impromptu, and streaming at this time is not making a liar out of me. Good morning. Good morning, everyone who's waking up, and good evening to everyone who's staying up at this unreasonable hour. All right. So, last stream I did on Tuesday, I did a little bit of a walkthrough of how Slearsgovy's POC works, how Flo's hint that he put out on Twitter kind of worked in with that. In this stream, I'm going to be clarifying some things that I was a little bit unsure of in that stream, and I also think I have a pretty solid strategy of a different way to attack this bug, new exploit strategy, which I hope will be more stable and more reliable. But reliability is one of those things where it's only really easy to tell once you've done it. You can come up with all the theory, but it's when you implement it is when you see exactly how reliable it is. But I think in theory it should be a cleaner strategy. I think, although it does involve racing, so it's a little bit fun too. So I'll cover that. I've done some really cool visualizations in Google Slides. I don't know if they're really cool, but they're useful. Partially for the stream's benefit, mostly for my benefit, to be honest, because trying to visualize the system state with this bug is very difficult. There's a lot of moving parts, so I basically spun up a Google Slides and basically jotted down where I want my strategy to go to try to plan it out, and I'll be following that for the implementation, essentially. So I will cover that a little bit. I've done a few more kernel modifications as well on FreeBSD and a VM, just to tell me what's going on a little bit better. As you can see, I make it print a lot of shit. Yeah, it used to print even more than this, actually, in some of the older runs. This is an even older run. This is like 1,300 lines of debugging. Thank you for the 100 bits, Kubli. Will we have an ETA this stream? I do not do ETAs. I hate ETAs. There's literally nothing good that comes out of putting an ETA out. If you meet it, people were expecting it, they don't really care. If you don't meet it because you hit an unexpected roadblock, people get upset. It's a lose-lose. I don't do ETAs. Hey, Belika. We're gonna go through a strategy that I've been thinking up and kind of walk through it, because I think it'll be interesting to people in the stream to see what my thoughts are with how I want to exploit it. It's 11:12 p.m. I know. It's a very weird time. Where is Teamstar Russian? We are going to sync up with Teamstar. I don't know exactly when. I don't know if we'll be able to do it. Probably not on the weekend, because we don't really do streams on the weekend. But we will sync up with Teamstar. But like I said, we're not really doing the scheduled stuff at the moment. So yeah, I'll DM with him. We'll see when we get that all working. Retro Gamer, welcome in. Yeah, I guess over there it's a very reasonable hour in Spain. All right, so yeah, like I said, I've been doing a lot of looking around, messing around. I crashed the kernel so many times that I actually reset the iterator on the core dump count. In the previous DVM, I probably have like 120 panics just from trying different things, trying to verify that my strategy is not a crackpot theory that won't actually go anywhere. Hopefully, I'm almost certain that my strategy will work, but I can't say with 100% until I've actually implemented it, obviously. So yeah, we will be going through some of those Google slides. I will refer back to some code when it's relevant, because there are a few slides where I have code there, but I'd rather just refer back to uh, the tab I have open. That way I can scroll around and follow the control flow. All right, I felt like I was preparing for a conference or something when I was doing up these slides, but I swear they were mainly just to help me with this visualization with a few touch-ups to make it better for the stream. Okay, so some of this will overlap with a little bit with what we covered on Tuesday, but I think it'll be better explained, if that makes sense. Could be worse. You could be trying to cross-compile libraries. Yeah, I'll leave that to you. I'm not interested in doing that right now. I've exhausted my fun in that department with libcxx and LLVM. All right. So, how the double free works. So this I kind of covered on Tuesday, but I'll reiterate over it for people who are new, who didn't catch that or whatever. You have a bunch of sockets, right? Sockets 0 through 8 in this slide, so 9 sockets. And that's just because of space and making it convenient to see. And then you spray a packet into each one of those sockets, and each packet will get its own mbuff, or message buffer. So when you spray packets in, usually the usual behavior is each packet will get its own mbuff, because you don't want data colliding. You don't want a packet you sent on one socket to be colliding with a packet you sent on another socket, because that would be stupid. So yeah, each packet should get its own mbuff. But when you trigger a double free, you could result in two mbuffs that share the same, two sockets that share the same mbuff. And that's the basis for the Flows IP6 bug. So though in this case, in this little example, we have UDP sock 2 and 4, two different sockets, but they point to the same data. So that's where you can induce UAFs and do some interesting things. So yeah, that's our UAF pair. So first I'll cover what Sleer's Govey does for his leak and his corruption. So to start off with the leak, you spray tagged packets into the pairs to try to identify which sockets have that UAF setup that I talked about in the last slide. And then you also have leak pairs that are TCP socket pairs, and I'll get into those in a second. You free an mbuff on pair 0, and what that ends up doing is it'll free the mbuff used by both socket pairs here. So they're both floating, as I call it. And then you spray a TCP tagged packet into the leak pair, and you try to get a triple overlap. Now, this is something I didn't really cover on Tuesday's stream, but it's actually pretty relevant. Essentially, what you have here is a triple overlap. With a UAF, you would have an overlap, or like a double overlap, I guess. You would have, or I guess with a double free, I should say, which is a type of UAF. But anyway, what you're doing here is you're taking that double free, and instead of having two things that overlap together, you have three things overlapping at the same time, which is when this state gets a little bit crazy to track, and is why I actually had to do these slides. So by peeking, you can get the tagged packet that's in there to find the socket pair ID that you're going to be able to corrupt. Basically, the socket pair ID that points to this third tagged packet or into the overlap. And then we receive on pair 1, which will cause a free. It'll cause all three overlapped. I mean, they all point to the same place, but in the slide, it makes it easier to think of it as if it's like 3 boxes or whatever. They're all going to be floating. Then you spray a stack of file pointers into that using the leak pair that you found. And that will allocate a bunch of file pointers through the SCM writes routine, which I'll go to the code in a second. And that'll write file pointers onto into your mbuff. And then by reading on that leak pair, you can leak kernel pointers. The leak is actually pretty simple when you step through it and break it down. So SCM writes. Let me get into this for a second. So I will enable dark mode, do not worry. It's just it messes with Google Slides, so I had to turn it off. Where were we? User request. Yeah, this is where it was. Okay, so actually, let me bring up the FreeBSD man page as well, because I think that will be helpful. Okay, so when you're creating sockets on Unix, you can create a few different types of sockets that have different purposes. You can have Unix sockets, which are basically local. You usually use them for IPC, and you can also have your more typical sockets, your iNet sockets that you use for communicating with a remote host. Now, Unix sockets allow you to do some pretty nifty things, and one of those things it allows you to do is send control messages over the socket, and you can actually pass file descriptors through, because that would be used. The primary purpose for that is IPC, I think, because they also allow you to pass credentials through as well. But anyway, yeah, you can pass these messages through that you can use to pass file descriptors, and how it does that internally is there's two main functions that are of note. I'll bring them up in Sublime Text, so I have highlighting. You have UNP externalize, this function, and what this function does is it'll take a stack of file descriptors from user space, and it will internally convert those file descriptors into file pointers, and it will store those. Actually, sorry, I got that mixed up a little bit. I think it's internalize that does that. Reading the code. Let me just see here. See message data. FP. Yeah. So internalize will take a stack of file descriptors. It will look up the file descriptor table of your process, and it'll look up what the file pointers are that are attached to those file descriptors, and it'll replace them internally. And then when you want to read those file descriptors on the other end, that's where the externalize function is invoked. And externalize does the exact opposite, right? It takes a stack of file pointers and it converts them back into file descriptors, because obviously you don't want to be passing file pointers back to user space. That would be a pretty serious info leak. So yeah, the user only ever sees the file descriptors. It's just in the kernel where they get converted between these two types. So yeah, I mean, that's the basis of this entire exploit strategy, both Sleer's Govies and what I want to go through with. So we'll go back to the slides here. So these are all file pointers in the leak, right? So you may ask, when I was going through that exploit strategy, why do you even need the TCP socket pair as well as the UDP socket pair, right? You might just think, well, why can't I just spray file pointers into the UDP socket pair and then just read on the other socket I already have? Why do I need a triple overlap, essentially? And that's because you can only send those SCM writes file pointers. You can only use that trick on Unix socket pairs. You can't use that on remote sockets. And that's somewhat reasonable. You're never going to be passing file descriptors to a remote socket. Even if you could, it's not going to be useful to them. There's no legitimate use case for it, right? Did you show the line with the UAF already? So I'm kind of brushing over the technical details of the bug, because we already covered, like, I think I covered that really thoroughly in the first couple streams I did a couple weeks ago. So I'm talking about it and how it can be used, but I'm not going into the deep details of how the double free happens at the moment. No problem, I'm behind. Yeah, no worries. I mean, if you want to catch up on that, I think Z set up a command. I think it's the bug command. Yeah. So you can see the bug command. There's a GitHub advisory that the flow submitted to Apple, because it also exists in Apple, because they share some code with BSD when it comes to the networking stack. All right, so yeah, that's why you need that triple overlap. When it comes to points of failure for the leak, there's a few different things that can go bad on you. One of them is you can fail to trigger the overlap in the first place, which is, on a single CPU, is pretty rare, but on multiple CPUs, on a FreeBSD VM, it's actually really hard to trigger an overlap. On PS4, though, I managed to trigger an overlap with TeamStar. So it's a little bit weird. It's like on some of these points, the PS4 might be more stable than a FreeBSD VM when it comes to like points of failure. It's a little bit weird. So yeah, some of the other things that can fail is failing to reclaim that mbuff when you're identifying the TCP socket pairs, and then also failing to reclaim it again with the file pointers. But those latter two are pretty unlikely. Usually if you fail on the leak stage, it's going to be that first part. You're going to fail to find the overlap. So that's the leak, which is cool, but it doesn't get you all the way there. What you need is the corruption. Finally, I can watch it online. Greetings from Russia. Welcome in, man. I mean, that is a benefit of doing it at the time we are. We get to see some people that usually don't get to tune in live because they, it's not a good time for them. But yeah, I mean, that's it's cool that we can get some of those people in today. So corruption is where things get interesting. So it starts off the same way as the leak. You try to identify your UDP pair that has the shared mbuff by spraying tagged packets. Basically the exact same thing. Although in the second stage, you attempt to reclaim the on the UAF pair. You attempt to send a shifted fragment. And here I'm going to refer back to code as well because it's really not easy to capitalize this in slides. But let me take you guys to what a shifted fragment is. So send shifted fragment. So a shifted fragment basically sends a hop-by-hop header. It sends a routing header, a very large empty routing header, and then it sends a fragment header deep into the buffer, right? 232 bytes in. As opposed to a regular fragment where it goes hop by hop, then fragment header immediately afterwards at only 8 bytes in. So that gets sent on it gets sent on the raw socket, but because the raw socket and the UAF pair are going to be occupying the same mbuff, again, you have that triple overlap where UAF pairs 0 and 1 overlap with the same mbuff, right? And that shifted fragment is sent as a non-final packet, which is important. It has the more flags set to true. And the reason that's important is because it relies on being able to send more packets later on to finish it off, basically. So, yeah, once again, we peek on the shifted fragment on the UDP socket, which will give us the raw header information, which we wouldn't usually be able to get through the raw socket, but because that double free, we can get it elsewhere. And that will allow us to get the identifier of the packet that ended up occupying that mbuff, which is useful because that's going to be needed for constructing the later packets to go with the first shifted fragment we sent. Little Lalo, oh, welcome in. Awesome you were able to make it too. So, yeah, once again, so we have an overlap with the shifted fragment. We free on the other pair. That results in the mbuff floating. And then we spray a stack of file pointers into that space. And now the raw socket and the UAF pair all point into into that stack of file pointers from the SCM Rice trick. And then you send the rest of the large packet fragments in the final fragment, and that will trigger an overwrite on this stack of file pointers. And there's some heap grooming involved there, which I kind of just skip over. But yeah, the final fragment is sent, and then when it goes to call that IP6 get prev header on the final fragment, it'll actually it'll smash over the stack of file pointers because that's overlapped with the previous fragment, basically. That's the basis of Flow's hint, and that is why you're able to smash the least significant byte of that file pointer, which allows you to misalign it and get the arbitrary code execution by way of faking a file structure. So this is what a debug log looks like in the kernel from my prints of what's going on with corruption. You can see here UDP socket 0 and 1, they share the same mbuff at 2B7BE00. UNP internalize, which is that function that allocates the set of file pointers, it's writing into that same area in the C message data. And then on the IP6 get prev header on that final packet, you can see it's also hitting the exact same area. That's where that triple overlap comes into play, basically. And when that happens, it smashes despite to 06. Balika, thank you for the 200-bit cheer. Appreciate it. I'm just seeing something in chat. This exploit is useless. No one uses IPv6. He is just using buzzwords. Asking a question, he ignores it. I mean, what? If you're talking to me, like, what question are you thinking I ignored? Are you talking about the socket pair with disaster recovery? Why not just use a load balancer? I'm not really sure what you're... I mean, I think that's trolling, so that's why I ignored it. Because I just want to keep on a roll of what I'm talking about, dude. Alright. So, yeah, that lower byte gets smashed. You get code execution, and then that's where the hello kernel world comes from. And the kernel log is from the kernel payload that gets ran. So there's a few other questions with the corruption that you might be wondering, which is like why those shifted fragments result in that corruption behavior. And that's basically the lower level details is because the offset is too large. So where it should be returning the next header, it doesn't. It ends up returning the current header, which is where it gets that overlap with the stack of file pointers. The corruption stage also has a few points of failure. Once again, it can fail to trigger that overlap. It could also fail to reclaim the mbuffs, and you could also crash on flushing on a messed up socket. Like I think Slearsgovy, he closes some of the all the sockets that weren't involved with like the marked bad file descriptors. But if you close one that did get messed up, then you get like that SB flush panic that we've seen so many times when we were testing on the PS4. I heard Slearsgovy successfully executed the 7.02, and now he's porting to 7.5x. Yeah, I mean, I don't know. It's very possible. I mean, some people were linking me to some like commits or some repos that Slearsgovy modified over the last couple days. One that had a 7.50 branch. That was just the bad hoist repo, which is like all WebKit. He might just be preparing that for when he does finish the kernel exploit. I don't think that really hints that he has, per se. That said, he could have as well. Like, it'd be totally fair if, like, it wouldn't be out of my expectations, basically, if he did. Because he's had this strategy worked out on a FreeBSD VM for a while. So he's probably been playing with it and trying to port it to PS4, and he might have been able to find some ways to make it more reliable. Because there probably are ways to do that. But I kind of wanted to go my own way because there's no sense in really treading the same ground. You know, he's obviously going to take his strategy and try to make it work. So I thought I'd try to go a slightly different way, which I am, and I will cover in actually just in a minute here. I'm almost at that point. Morning from the UK. Morning, man. All right, so yeah, I have a new strategy. And I'll quickly go through a methodology that is the basis for my new strategy that in itself won't work, but there's a way you could try to make it work by introducing some multi-threading and racing in there. So we're turning a non-race bug into a race, kind of, when it comes to the corruption, which is weird. Generally you want to avoid race conditions, but I mean, I think this is a cool strategy, so I'll go through it here. So again, my corruption kind of starts the same way. We spray those tagged packets, get the pair of sockets that overlap. And then I receive the mbuff on 0 to free it up. That way we cause that mbuff to float. We spray a TCP tagged packet in there to try to identify what the corrupt pair was for the TCP socket pair. Very similar to the way the leak strategy works. Yeah, and then I free again on UAF pair 1 to get that tag packet released back to the allocator, make it float. Thank you, Brian Cabot, for the tier 1 sub. Welcome in, dude. So, yeah, once we have that mbuff floating, we try to reclaim it with a stack of file pointers, much the same way that the leak works, once again. So that those file pointers are going to be shared between the UAF pair, both UAF pairs, and the corrupt socket pair. And then we would free again, ideally, to try to overwrite those setup file pointers with a set of fake file pointers that we set up, right? So we try to set up some fake file objects in userland. We take those pointers, try to spray them in. And then when we try to use them on the corrupt pair and we read those FDs, we hopefully get a malicious file descriptor constructed for our use. And then we issue an operation on it to go to the fake function table we set up, and we get code execution. In reality, this strategy on its own will not work. The reason for that is mbuffs keep some internal state tracking information in their headers. That includes how that mbuff is supposed to be used, how it's supposed to be parsed. And like I said from the man page, this is known as a control message. And when you send control messages, it keeps track of that by setting the empty control flag in internally in that mbuff. And this is actually what Slearsgoby talked about on Twitter. I'll quickly bring up his tweet. Yeah, so he had this initial tweet of, are they really storing kernel pointers inside of mbuff's data area, which refers to the file pointers. And then the next thing he said was, unfortunately, type confusing these pointers does not seem possible due to it using a special mbuff type, empty control. It may be possible to turn this into a UAF on struct file, but that is also zone allocated. I'm not totally sure what he was saying about how you could turn it into a UAF on the struct file. That I don't totally follow there, but basically this is the important part. It uses this empty control flag, right? And yeah, this is the code that's responsible for that. Once again, I will jump to the actual code to demonstrate what's going on there. So this is the SO receive generic function, which is, as you would think, it's responsible for receiving data on a socket, and it gets called when you call like resv from or whatever. And inside of this function, the externalize function pointer can get called. And this is what I was talking about earlier with that UNP externalize function. But this will only get called if the mbuff type is empty control. And if we just overlap with the strategy that I just talked about, you're going to end up removing that flag. And if you remove that flag, then it's not going to take this path. It's not going to use your fake file pointers, and you're kind of left sitting screwed when it does that. You're left high and dry. But there's a way we can get around that, I think, by using racing. So if we use two threads to abuse the UAF, we use one thread to start that read FD on the files on the corrupt socket pair. And then on the second thread, we try to abuse the UAF to get our fake file pointers substituted in. And we do that after we have that flag get checked. Then I think we might be able to make it work, right? Thread 1 will pass that empty control check, but it won't use the file pointers yet, hopefully. Thread 2 will then cut in before those file pointers are converted to file descriptors, and it'll fake them, spray them in there, and then when thread 1 resumes, it'll use those fake file pointers, and the strategy is kind of alive again, I hope. So yeah, I'll quickly walk through that. The other thing is here, like usually when you're talking about race conditions, there is a question of locking and stuff like that. That is going to make zero impact here because we have direct control over the mbuff. We can induce a use after free on the mbuff. They could use a billion locks. It wouldn't make a difference. So yeah, that's not really going to be our concern. So here's a little bit of a diagram of the new way, right? We start off by starting two threads. We run the first one, and we have that triple overlap of where we left off with the file pointers being pointed to by both the corrupt socket pair and the UAF pair. But they're legitimate file pointers. They're not, we haven't corrupted them yet, right? So then thread 2 will run, and hopefully thread 1 has already passed that empty control check. Thread 2 will run. It will free the mbuff on pair 1, which will make them the mbuff float again. Then we spray in our fake file pointers. We put our evil ones in there. the ones we control in user space. And then thread 1 will resume, and it will hopefully use our fake file pointers. And then when it goes to construct the FD for the other end of the IPC, IPC being inter-process communication, sorry. I am using some 3-letter acronyms without explaining what they are for people not familiar. So yeah, like when it receives the file descriptors on the other end and it goes to do an operation on that, it'll use our fake file pointer, follow its fake function table by extension, and it will, we'll get code execution. So that's the basis for the strategy. Going at it from a code point of view, essentially, we want this so receive generic function to run. We want to get here, and then anywhere along here, including inside of this externalize function, as long as the loop for converting the file pointers, file descriptors hasn't expired. Anywhere in this window is fair game for thread 2 to run. Kal-El the Legend, thank you for coming in with the Twitch Prime. Little Lalo says, isn't that really risky when thread 1 is already using them while you free and spray with thread 2? It is risky. If any other mbuffs get substituted in when that happens, then it's possible the system will blow up. Because if it gets uncontrolled file pointers in there, or just any data that it tries to treat as a pointer, then yeah, things will go badly. So it is a bit of a risk, and that's why I don't want to say for sure that it will be like super stable or reliable. Because unfortunately, like, this bug is already kind of hard enough to hit as it is with the with it being inside of the mbuff zone. But the other problem is mbuffs are used a lot internally by the system. I found this out actually when I was putting in my debug statements in the kernel. When I just put like a print on the, I think it was a function that parsed mbuffs, like all mbuffs that came through. And there were just like hundreds being allocated, and the system wasn't doing anything. It was just sitting at a terminal. I wasn't typing commands. I wasn't doing anything. It was allocating mbuffs and freeing them in the background. So when you have a lot of movement, it makes UAFs a lot shittier to work with. So it'll be interesting to see what stability looks like. That said, that problem will be the same problem that Sleer's Govey faces. So I don't think my stability would be worse than what Sleer's Govey does. I think it would either be better or on par, basically. Just looking at the code and like the theory of it, I think it would either be better or on par. I don't think it would be worse. There might be some scheduling shenanigans you can do too to try to give your CPU core and your thread priority to basically make it more likely that you win the race against any other process using mbuffs. But yeah, I mean, it'll be interesting to see when we get to the implementation stage. Best case scenario, you guys get it working. Would you carry on tweaking it or look into PS5? I don't know what I'm gonna do when it comes to PS5. At the moment, I don't have one because they're really hard to get where I am. It does sound interesting from a security mitigations point of view. No doubt, it has supervisor mode, execution prevention, and access prevention. It has execute-only memory, apparently. And I was already, having a little bit of fun trying to brainstorm how you'd get around the execute-only memory by doing, hardware side channels or something. Because it would be really tricky to get around, actually, if you're trying to do ROP. But I don't know if I'll actually, go hard into PS5 research like I did, how I got started with PS4. Because, mostly I just wanted to get into homebrew stuff, and I wasn't on the bandwagon to get a 1.76 console. I was on 4.05, so that's why I got into some of the exploitation for PS4. And while I did I do love the exploitation angle, which is why I'm doing these streams as well. My main end goal was to try to work on homebrew and do an open tool chain, which we have done. But Homebrew's been a little bit more daunting and depressing than I'd hoped it'd be on console. It's so much more work, and the system is so outdated now that you don't really gain much through Homebrew. Like, you might as well just run whatever you'd run in Homebrew on your PC. A PS4 is basically a worse PC. So, Homebrew is, yeah, it's a little bit less enticing to me, I guess, than it was a couple years ago. And I do not care at all about piracy. I couldn't be bothered. So, yeah, I don't know if I'll do anything with PS5. I don't know if I'll feel it. For PS5, start installing FreeBSD 12. I actually, apparently, I don't think it actually uses FreeBSD 12. I think 12 is too new. Because they would have had to start development on the PS5, like, operating system years ago, right? And 12 was only, like, when was 12 released? I don't think it was that long ago. It was like maybe 1 or 2 years ago. Yeah, 12 released in the end of 2018. So I think it's more likely they're using 11. So I think 11. If you wanted to look at like trying to get something in advance for the PS5, you'd probably want to look at 11. Switch Homebrew is great. Yeah, honestly, nothing will ever really beat the Switch and the Vita when it comes to Homebrew, because the portability aspect is just so cool, and it's something you get that a PC doesn't offer you. It doesn't offer you the portability. I guess you can have a laptop, but the Switch is a really cool console. So yeah, whereas the PS4 is basically a giant brick, and it's not very portable at all. So yeah, Kiwi said it was 11. Yeah, 11 would make a lot more sense to me. Um, but yeah, I mean that's the basis of the exploit strategy is trying to turn it into a race on this area of code essentially. Um, so work over the next day or two will be trying to implement that. I've already started a little bit on trying to figure out I guess, how UNP internalize and externalize kind of work together. I've been printing out the mbuffs and how they work. So you can see, like, for example, on this first UNP internalize, it takes the C message data of 2EA E000, and that will be shared with one of the externalize calls right here. So that kind of confirms to me that I think my strategy will work, because it's using the same area of data that we can do a controlled UAF on. We can do a UAF on that data whenever we want. Now, if you run in a single-threaded context, like what Slur's Gobi does, you kind of have to set things up so that your UAF runs between two operations, two separate operations. Whereas if you introduce the idea of multi-threading and you run two threads, you can trigger that UAF while the routine is running, and that gives you a lot more possibilities. Another route that I looked at that unfortunately I couldn't really find a good vector for was actually reviving Teamstar, or sorry, not Teamstar, CTERT. CTERT's really old exploit strategy. I actually mentioned it to CTERT that I wanted to reuse that strategy, but I couldn't find a way to do it. Let me see if I can find it really quick, just in case you guys are curious on what I'm talking about. Because he had a bug, a send message overflow. I don't know how many people will remember that. I don't think it was really focused on too much at the time. But yeah, he had a send message heap overflow, and this was again in the mbuff zone. And what he ended up discovering was if he overflowed for long enough, you could actually corrupt an adjacent zone's metadata. That way, whenever anything got freed from that zone, if you had a UMA-Z free call, you get code execution through through a function pointer that gets called from that zone. This was a really cool strategy, I think, and I really wanted to revive it, but I can't find a good option to get an overflow. Thank you for gifting in AOJ. I'm going to say AOJ. Thank you for gifting him in Super Viked Soda Pop. Got some funny names today. Thank you for the gifted sub, though. Appreciate it. Yeah, so I was hoping to find a vector where I could trigger a heap overflow in the mbuff zone. Maybe try to find a C message somewhere that had a length that I could smash. Unfortunately, like literally everywhere I looked at that used a C message, it cached the length locally and then did validation on it. So there was no race condition angle. You couldn't switch the data out. I mean, you could, but it would never get used, so it was useless. Um, so I just kind of doubled back on using a similar strategy to Slear's Govy, using the file this file trick because it's really cool. But instead of doing that one byte right with the shifted fragment, I want to just do a race and hit it that way. And I think that'll work out well because even if we pop the flag after we race, if it's after this check, who cares? Like it doesn't matter anymore. That flag can get destroyed. We're already in the code path. It's already game over. So this timing is perfect for us folks Far East, South Asia. Also really good for Germany. Yeah, actually, Teamstar might actually be awake right now. I don't know if he probably wouldn't be able to jump in. He's probably busy, but I might send him the VOD of this stream afterwards to see what he thinks of my strategy. See if I'm stupid, if I missed something. I don't think I have, but it's possible that I have. It's around 9 a.m. here, so maybe he isn't. Yeah, I'm not sure what his sleep schedule is like. It's probably a lot more normal than mine, though. I usually wake up at like 2 p.m. my time. It's really messed up. It goes back to when I used to work well, I was gonna say a day job, but it wasn't a day job. I used to work a night shift, so my sleep schedule never came back after that. I used to work till midnight, and yeah, I haven't worked at that place for a long time now, but it's just I've gotten so used to this time frame, which is why I'm able to stream at 2 o'clock or 3 o'clock in the morning. I never learned C or assembly in university, only hipster Java and C# stuff. Any good resources on where to start? I would definitely recommend learning C before assembly in terms of order, because typically when you learn assembly, it's a lot easier to learn it if you can put it into like a higher level representation. Like being able to go back and forth from like a C representation and an assembly representation is very useful. And if you don't know C already, then you're not going to be able to do that. It's going to be a lot trickier for you. There used to be a site that I liked a lot. It was Learn C the Hard Way. It's not free anymore. You might be able to find it on like like archive.org or whatever. I think it's like a paid book now, but some people also it's kind of a hotly debated resource, I guess. There's also some people who really don't like Learn C the Hard Way. I don't know if I have a great resource for learning C, to be honest. You might have to look around a little bit. In fact, I should actually Z's not up at the moment, unfortunately, but I should probably talk with him to see if we can find like a good solid recommendation for learning C for like to put out on our day zero stuff, because that would be useful. When it comes to assembly, I do have a resource. I've talked about it a little bit before. It's opensecuritytraining.info. These are quite old now. They are being revamped. Neokova is working on a V2.0 of these courses, but those aren't scheduled to be dropped until the end of the year, I think. So until then, I mean, the courses that are already there are really good, even if they are a little bit dated. It's not like the x64 architecture, or x86 64 architecture has changed that much in the last like 10 years or whatever. There might be some new extensions on the instruction set, because x86 has like a billion extended instruction sets with like SSE and AVX and all that shit. But generally, I mean, you don't need to learn that stuff unless you're looking to reverse like 3D game engines or something. Most of the stuff you're going to be reversing is going to be using pretty common instructions in the base instruction set. Is C much different than C++? Yes. K9 actually in chat would he gets very heated when people try to say that C++ is basically C. It is quite different. There are people that write C++ as if it's C with extensions, or whatever it used to be called. But it's kind of grown and evolved pretty well diverged from C when you're talking about like industry grade C++, because you've got a lot of like stuff with the object oriented stuff, obviously with classes and methods and all that shit, but you also have like the smart pointers and all that fun stuff. I'm not a C++ fan. I don't really like it, but if you're looking, like, if you want to do exploitation or security research and you want to do security research into browsers, it's pretty much a necessary evil. If you're looking at game engines or browsers, C++ is going to be standard. If you're looking at operating systems, like kernels, doing kernel security research, luckily you're spared from C++. It's pretty much all C in kernel land. Unless, except for Windows, actually. I think Windows uses a fair bit of C++ in the kernel. But if you're looking at like a Unix-based kernel, or like iOS or Android or whatever, it's gonna be C. Dumb question, but I don't quite get how you get code execution once you corrupted the mbuff. Does something in the mbuff get called eventually? Right up on the volume just says you can write /corrupt, but I don't see where it's eventually called /executed. Okay, that's a fair question. I did kind of skip over that, so let me go into that. So this mbuff, like I said, it has a stack of file pointers inside of it, right? So let's take a look at the file structure, or the file object, which you'll be able to corrupt the pointer to. So this will be in file.h. I don't know why Watson is taking so long. Oh, is it? No, it's not down. I'll just go to it myself because the search is taking forever. All right, so this is the file structure. Let me bring it into Sublime Text so it's not as ugly to read. Okay. So the file structure is a pretty critical structure in the kernel. It's going to be used for, well, anything that has a file that's recognized as a file. So that could literally be a file on the system, or it could be a device driver, although that gets a little bit more complicated because device drivers, yeah, devices are another beast entirely. But yeah, basically anything that you get a file descriptor for is going to have this backing file structure. So there's a few like really noteworthy fields in here, being the data, like basically the first four: the data, operations, credentials associated with it, and the vnode. The vnode is the internal like file system node for it, which we'll just ignore for now, as well as the credentials. Data is going to be any specific data to that file descriptor. It's kind of left as a container. It depends on how that file is being used and interpreted. But file operations, you can think of this as kind of like if you're familiar with C++ and vtables, this is like the C equivalent of vtables. This is a function pointer table, I guess I would call it. So this fops member, if you can corrupt this member, that's where you get the code execution, is when you can fake the file operations pointer. So let me get that structure as well. It should be in this file too, I think. I don't know why they would move it. Oh, well, apparently I'm a liar. It is in a different file. So let me do that. Or it's not? What? Why didn't it find it? Okay, whatever. I don't know. I don't know why Chrome's Control F let me down there. Whatever. So this is the file operation structure. So when you go to call anything on a file, like let's say read or write or ioctl or pull or kq or whatever, anything like that is going to go through the file structure. It's going to look up the file operations table, and it's going to follow whatever function pointer is in that location. So you can see here, read, write, truncate, ioctl, pull, kq filter, stack, close, all that stuff. So yeah, I mean, the basis of it is if you can corrupt a file, or if you can fake a file object, you can fake this file operations table, and then whenever you go to do something on it, you can control where the control flow goes. What Sleer's Govey ends up hitting in his POC is he does a select on the corrupted file descriptor. I'll take you guys to that actually in the little annotated version I have. You can see here after he does his trigger and he gets the overwrite, he does a select here. And when it goes to do this select, it follows the fake function table he has set up at 2edbeef0000. And you can see he casts it to an array of void pointers, and at 4, he initializes it to the kernel payload, which is the routine he runs in kernel space in ring 0. Sorry. So the fourth member, if you look at the file operation structure, we have 0, 1, 2, 3, 4. He corrupts the poll function pointer, and that gets called internally when you select on a file descriptor. In theory, he could use any of these. I've actually done a similar type of exploit. I think 4.05, I corrupted a file structure as well, or I faked a file object. What I decided to go for the ioctl function pointer, so I could just issue an ioctl on it and get code execution. You could do that here too. It's just what he chose to go for was the KQ filter. I think it's partially because of the way he can control arguments that go into it. Because if you look at his kernel payload, he does some cleanup actually inside of this kernel payload. See these lines with TD190 bad FDs? What he's doing here is he's cleaning up the socket receive and send buffers for all the file descriptors we corrupt, and he's setting the fields to 0, because if you don't, then you will crash the kernel when those sockets go to close, because they're in a tainted state. So this is also why you'll get an SB, like a panic with this SB string in it. You'll get that if it fails to run the kernel payload, because it can't do that cleanup and it just blows up. So yeah, I mean, there's basically it is a long road to get code execution with this bug. And it comes down to two things. It comes down to the fact that it's in the mbuff zone, which when you're dealing with a UAF inside of a zone that's not a generic allocator, spraying becomes far more difficult. And the other problem is well, it's actually like the biggest problem is related to that, right? There's flags that you can't control. So anything that uses an mbuff, if you can't control the type, which you can't through a spray, it gets very tricky to exploit, which is why I have to go with the race and why he had to go with the shifted fragment to smash or overlap a header with another mbuff and smash that way. There might be other ways to exploit this that would be interesting to see, like later on, if there are any other ways. There almost certainly is. I mean, when you're talking about kernel, there's so many different code paths, and mbuffs are not like it's not like they're only used in one location in the kernel. They're used in quite a few. Like if you look at, I forgot the back doesn't do what I thought it did on this site. If you look for M2D, which is a function that converts or it gets the data container for an mbuff, you'll find or actually, let me do that again. That search will take forever. Yeah, if you do M2D, which will get the data buffer for an mbuff, you'll see there's hundreds of XREFs. A lot of them are in devices that you're not going to find on the PS4, like net IPsec, like these net 802.11, like netgraph. Like a lot of this stuff isn't going to be on the PS4, but it is used in quite a few places, and it only takes one that has like a promising path for it to be abused. What is the name given to multi-line edit? I'm not sure what you're referring to there. You'll have to clarify a bit for me. Sublime text? If you're wondering how I did the multi-line edit, like how I did, I'm guessing you're talking about how I did, like how I did this. The way I do that is you hold down Control and Alt on the keyboard, and then you use your arrow keys to select the um, select the cursor on the line. I don't know what the official term is for that, but it's really useful because it also works with the home and end keys, so you can. It's very versatile. I love it. It's really unfortunate that some of the editors I use don't support it. I don't think Visual Studio supports it. It's really annoying. Although, funnily enough, I'm pretty sure Visual Studio Code does. Yeah, Visual Studio Code does, but I don't think Visual Studio does. It's really strange. VS Code 2 with... Oh, you have to use Shift? Yeah. So on VS Code, it actually is the same keyboard shortcut, but that is one thing with Visual Studio that I really dislike. It changes so many keyboard shortcuts on you for absolutely no reason. For example, one I remember is you cannot comment out code in Visual Studio unless you change it. By default, you can't comment out code in Visual Studio with Control/. You have to use Control Shift K or something. It's really weird. I don't know. It's just Microsoft, man, changing everything for no reason. Vim calls it Visual Block. Okay, that's interesting. I never knew that. You can drag select with middle mouse for that too. Oh, that's interesting. I didn't know that one. I'll have to try that one out. All right. But yeah, I mean that's the basis for the route that I want to try to go. That I'm going to be working on the implementation for. I just wanted to do a, kind of catch up stream for talking about that, the way that I was going to go, because when I left it off on Tuesday, I covered how Sliersgovi's POC worked and where I think I was going to try to go for my strategy, but I didn't really have one figured out yet. I was just kind of looking around and looking for things of interest and spotted some. Like I was also thinking of trying to do something with the packet options for the setsock ops. Unfortunately, those just didn't really pan out. They didn't really do anything interesting with the M buffs. Well, some of them did, but they did that caching I was talking about earlier, so it didn't really work. Um, but yeah, I'm pretty confident in this strategy. I think it's cool. I think it'll work out. So it'll just be a question of how reliable it is, I guess, which, I'll find out. And hopefully there's not a roadblock in the way of one small line of code that I missed that blows up my strategy. But like I said, I've looked over it a few times and I don't think that's the case. But we'll see. Worst case scenario, we can fall back kind of on what Sliersgovi was, doing and see if we can work on a more reliable route. But I don't think I'll have to do that. We'll see. In terms of like ETAs and stuff, though, yeah, I don't really give them, because I think a lot of people who don't do exploit development a lot seem to think that it's like like if you're good with exploit development, or if you've ever written an exploit that you can predict when it's going to be done, like the exact route to take to get there. It's really not. Exploit development is like a maze. You can end up going down a path and then find it's a dead end and have to backtrack all the way and go a different route. Um, that's like you can't really put a fine point on exploit development. It's not like regular software development. You're not trying to like with regular software development, you can just, if you're looking to do something and you can't figure it out, you can probably look it up and copy paste something in there or something. Or but like with exploit dev, pretty much every scenario is unique. At least in modern exploitation. Maybe in some of the older exploitation, like 90s and 2000s, with like IoT, I guess nowadays, it's kind of like copy paste verbatim. But in modern exploitation, there's very few scenarios that are alike. It's very specific on the bug. It's very specific on the system, the target. So yeah, and I do kind of wish that more people like recognize what goes into exploit dev, because a lot of people think that you just flip a switch and it's done. It's like It's not, you know. Maybe for some like amazing people like QWERTY, but I'm not him. So, uh, Dan, no Stack Overflow copy pasting. It's a hard life. Um, I am alone right now on the stream. Yeah. I did say earlier. I'll repeat it for anybody that just came in. Uh, I am gonna be doing a sync up stream with Teamstar. I just don't know when exactly. Right. Um, it's a bit hard to coordinate with Teamstar because we're in such different time zones. He's in Berlin time. I'm in Toronto time. So it's you got to find that window where it works for both of us, and usually like when we were doing the scheduled streams on Thursdays, I was doing them 5:30 p.m. Eastern my time, which, to be honest, I don't really like streaming that early. Like I said, I usually wake up at like 2 p.m. I'm usually not even like fully awake by the time those streams go up. Like it takes me a few hours before I'm like ready to go. And that's right on the beginning of that. I like streaming later on, but it's kind of unreasonable to expect Teamstar to want to get on at like you know noon his time, or sorry, not noon, midnight his time, and then go for like 4 hours or something. That's not really a reasonable expectation on him. So yeah. Um, but we'll let you know, I guess, when we get Teamstar with the sync up stream. I don't know if we'll announce it too far in advance, but in the announcement that I put out for when we go live, I'll mention the Teamstar is with us. Yeah, hopefully that happens soon. Crypto mining on PS4 Pro, good use for old consoles or too much power consumption? Um, I don't know actually how well mining crypto would actually work on the PS4 Pro. If you're talking like it also depends on the algorithm, right? When you're talking about cryptocurrency mining, the most popular thing right now is Ethereum and altcoins that are based on Fhash, which that is an extremely memory bound mining algorithm. It's pretty much entirely memory bound actually. So I don't know what the memory bus width is on the PS4 Pro. Um, but I'm sure someone somewhere has benchmarked like what the hash rate it could produce would be. I would guess it's probably not good for the power ratio. It's probably going to be drawing a lot of power for not a lot of hash rate. It's probably going to be pretty bad compared to like GPUs. But I mean, it's something you could look into, I guess, if you wanted to do that. The other problem you have with like PS4s and consoles in general is the cooling is pretty garbage. And when you're going to be doing mining like that, especially, well, PS4 might not be too bad because it's GDDR5, but I mean, when you're doing mining like that, the amount of heat that gets pumped out is insane, and the cooling solution is just not good on consoles. So you might end up like with really high thermal degradation or something with mining on a console. I don't know. There are dedicated chips that are optimized for mining, so you always be behind them. Yeah, there's ASICs. Um, Especially in Ethereum, they've really been creeping into Ethereum lately. Um, it's been speculated that there's been a lot coming online. Um, yeah, you'll never beat those chips. And even if there weren't ASICs, there's people with GPU farms with like thousands of them. So you're not going to beat them either. You might be able to make a little bit, but you'd really want to look at how much power draw the PS4 would be using, because if you're going to end up spending more in hydro than you would be making like from actually mining and block rewards, then it's not worth it. If you want to heat your home and make some money, you can use multiple PS4s. Yeah, if you need heat, I mean, I'm pretty sure this was a long time ago. I think this was like 2017 or 2018, but I remember QWERTY. I think he was mining Ethereum actually, and he had like a little warehouse, and he was funneling the heat from the GPUs into a duct or something. I don't know. I probably couldn't find that tweet. It's from a long time ago, but yeah, I thought it was pretty funny. Um, yeah, if you need heat, mining's good for that. So yeah, that's my strategy. I might make these slides public. I don't know if anybody would actually be interested in that. These were kind of like some. I pretty much hacked them together in like 4 or 5 hours when I was trying to work through what I wanted to do and work out my strategy. Um, I don't know if these slides will really be interesting to anybody out there, but in the off chance they are, maybe I'll put them public. I'll probably if I manage to make my strategy work and exploit it the way I want to, I'll probably do like a video afterwards that kind of covers a similar thing with the slides that goes through it in a uh, more smooth, I guess, way, because these are kind of just thrown together and they're mainly for my own thoughts. But we'll probably do a video on the Day Zero channel if we get to that point. I would like to have a look at them, but I can also watch the recording later. Okay. Yeah, I'll probably put them out there. I'll put it somewhere. Sure, some people will find it interesting. I read that standard PS4 makes less than $1 a month. It wouldn't surprise me. Because like I said, with things like Ethereum where it's so memory bound, it'd be interesting how that works when it comes to PS4, because you got to remember PS4 has a unified memory architecture. It's not like when you have a GPU, let's say, right? Which are the most popular equipment for mining. It's going to have its own dedicated memory, right? It's most modern video cards in the last year or two. It's going to have GDDR6 or GDDR6X on board. The PS4 has a big memory pool of 8 GB, but it shares it between the CPU and the GPU. It's got like onion and garlic memory, as it's called. It's actually all the same memory, but when it's being marked for use for CPU, it'll go through the CPU caches to allow that to spy on it, I guess. Whereas GPU, it just goes direct to the GPU cores. But yeah, like when you're talking about a unified memory architecture like that, I wonder how it would work when it comes to memory performance. I don't know. I don't know enough about, like, I'm not enough of a memory guru to really be able to say definitively on that point, but it's interesting. Does anything surprise you? Uh, that's a very high level question. I'm not really sure where to go with that one. You probably have to narrow it down. There's lots of things that surprise me. Do you know some sources to prepare for OSCP BOF task? I'm guessing that's buffer overflow. I don't know much about OSCP. Um, I would say like Z has done some of the offensive security stuff. I think he's taken one or two of the courses. I don't know if he's taken OSCP. I don't remember, but he would probably be able to speak better than on that than I could. I don't really do certification stuff. I don't really care about it at all. But um, yeah, unfortunately, I can't really help you too much with that question. Does that mean the PS4 memory is French? Yeah, so um yeah, I think over the next day or two, I'm going to be trying to tweak this strategy on a FreeBSD VM. I'm going to be tweaking timings, trying to make sure the race works. Once I have it working on the FreeBSD VM, I'll port it over to the PS4. It probably, like on the porting stage, it probably would require timing adjustments. Races in particular on the PS4, I've kind of talked about it before, but I'll bring it up again. Races on the PS4 are interesting because the CPU is just trash. The PS4 CPU, at least the non-Pro, it's like 1.6 gigahertz. Even the Pro, it's like 2 gigahertz boost. Um, the IP6 is like not really that great because it's from 2013 or whatever. So, like race timings are interesting on the PS4. Um, in a way, I think it actually might be helpful. It might be more reliable on the PS4 because of that. So we'll see. Um, yeah, so basically, I'm going to try to get it working in a FreeBSD VM, and then we'll port it over to PS4. hopefully I will have it working on a FreeBSD VM before we do the next stream. And then the most of what we'll be doing on the streams after that is making it work on the PS4, and we'll be back to the beep counter and all that fun stuff. But yeah, it'll be a lot easier to tweak the timing on a FreeBSD VM early on in our adventure. I kind of said that I wasn't going to bother using a FreeBSD VM. My stance is kind of switched on that. For one, because I already have one set up, and I've gotten over and already had to trudge through the pain in the ass stuff with FreeBSD, which is like the initial setup. Now that I have that done, I don't really mind working in it as much, and it is so much nicer to test with. I'm kind of like Teamstar. I like doing test-driven development for exploit dev. So I like being able to tweak things, maybe change one line of code and run it, see what happens, observe the system state. You can't do that on PS4 because it takes like 15 minutes to reboot the damn system every time you crash. It's the worst. And even then, you can't modify the kernel and rebuild it for the PS4. The best you can do is like kernel patching and hooking, which is really hacky. Whereas on BSD, I can literally go into the user source and I can make a change to a source file, make install, reboot, and I'm done. It's just so much nicer to test on a VM. So yeah, I kind of switched my strategy a little bit on, or I guess my methodology a little bit on testing. I'm going to be using a FreeBSD VM and then port it over. I think it's just going to be so much quicker. Oh, is that Teamstar? Test-driven development for the win. People were saying you were probably asleep. He shows up. Nice. So you kind of missed the Teamstar. I was just talking through my strategy of what I want to try to do with doing a race condition. It's 9:20, right? I think over there it's 9:20. Yeah, it's a 6-hour difference. It's 3:20 for me, so. Just woke up. Ah, okay. Um, so where you just woke up, would you want to jump into a Discord and talk a little bit, or is it too early for you? If it is, I totally understand. But I do have kind of a cool exploit strategy in mind, and I did go over it with the stream, but it'd be cool to have like a second opinion on it. And yeah, little Lalo's been with us for a little while too. It's been we've got a little party going on. But yeah, just let me know, I guess, Teamstar, if you want to jump into Discord, I can jump in. But yeah, like I said, I totally understand if you can't yet. How much longer are you gonna stream? I was probably going to cut it off pretty soon in a few minutes, honestly. But if you want to talk in Discord, then I'll stay on for a while longer and we can have a discussion. We'll be on in a sec. Okay, cool. I'll go into the Discord then and wait for you. Sadly, we do not have Z with us right now. He is actually sleeping, like a normal person would be in our time. He's on a normal person's sleep schedule. Okay. Yeah, so I'm in the typical channel that we're usually in. All right. I guess while we wait, if anybody has any other questions in chat about like exploitation stuff in general or whatever, I'm open to taking anything like that. Since we did have a few questions on like where to get started in terms of learning C and learning assembly and stuff like that, there is a resource that, or rather a resource aggregation that Z put out there on our blog on the Day0Sec site. For those who haven't checked it out, by the way, we have a site with some blog posts. A lot of them are like our podcast episode recaps, but we also have a few write-ups there. I have like an Android write-up I did a little while back. I had a PS4 muscle write-up. We also have the YouTube channel, which has some of the discussion videos we've done which has some pretty cool topics we covered. Like recently, we did a discussion on where we think exploit development is going to go in the future. So that one was a fun discussion video. So yeah, if you want to check out any of those, we got that at day0sec.com. But the main resource I wanted to shout out was Z's post on getting started with exploit development. It does assume a few things on the reader. Like it does assume that you know C and x86, but and how to like use basic, Linux commands and use the terminal. But I've already pointed like a resource for assembly, for example. But some of this other stuff is some really good resources and explanations of why those resources are helpful for learning exploit dev. How much more time for exploit? Let's say I don't like giving out ETAs, but let's say 2023. I think that's probably a good date to put on it. How long is a piece of string? What type of video games do you enjoy the most? To be honest, the games I play the most nowadays are Factorio, because I can just kind of listen to stuff and play it and not focus too much. Hello, A-Team Star. Good morning to you. Very late night for me, or I guess early morning for me. But yeah, to finish off that question, yeah, like Factorio is what I play. I do play some Elder Scrolls Online, although they've been messing with that a lot, so I haven't really played that in a while because they've been doing a lot of dumb shit with the game. ZeniMax, that is. But yeah, Factorio is probably my number one at the moment. Alrighty. So, you ready to talk about some exploit stuff early? All right. So, I kind of went over some slides that I did on the stream. Partially, I did the slides for the stream benefit. Mostly, I did them for my own to try to visualize what I was trying to do with my strategy. I first went over Sleer's Govi's strategy. So I kind of reversed his POC and figured out what he's doing. I think I told you a little bit about it in DMs, but I don't remember how elaborate I got, to be honest.
Yeah, I think I've skimmed over it.
Yeah, so I mean the basis for that strategy and my modified one that I'm going to try to do is on local sockets, on AF Unix sockets, you can send these control messages. And I think that's like mostly for IPC and stuff. But one of the things you can do is send an SCM writes type of message to send file descriptors. And when you do that, you can pass in a stack of file descriptors, and internally in the kernel, it will rewrite those file descriptors into file object pointers inside of the mbuff. So you have kernel file pointers in the mbuff.
Oh.
Yeah, it's pretty wild. The way he takes advantage of that is
why would they
I don't know either. Yeah, I was thinking that too. They probably should have used a different zone for that. I kind of covered a little bit on the last stream. Like, technically, it's not inherently insecure because, like, that's all being handled in the kernel. The user space only ever sees the file descriptors, but it is definitely weird.
Yeah.
So, unfortunately, you can't just do a straight overlap, right? Because where it's those control type messages, there's the MT control flag that's set inside the mbuff header. So if you overlap and lose that when you try to fake file pointers, it won't take the path that you need for it to actually use those file pointers, right?
Okay, yeah, we had those issues.
So how the Flow, I think, and by extension Sleer's Govi, when Flow put out his hint, abused that was they got a a fragment, like a shifted fragment header, to overlap with the file buffer, and then abused a function that would write 1 byte into that. It would try to write like the next header ID into the previous headers, like next or whatever. And when it did that, it would smash the least significant byte of the file pointer that's inside of the mbuff. And when it did that, it caused a misalignment. It would cause the second file object to point, instead of in its own object, it would point into the tail end of the previous file object. And the reason that was a problem was you could basically overlap the fops field of the second object and the seek offset of the first object, and you could seek on a file descriptor to smash the adjacent file's operations table, and you can get code execution. So that was the essential strategy of Sleer's Govy and the flow.
So I maybe a little lost here. So basically, you're using a 1 byte heap overflow.
It's not exactly an overflow. It's more of like a 1 byte write into a overlapped mbuff. So it doesn't smash that flag, the control flag. It just smashes the 1 byte inside of the mbuff, which you can set up to have a file pointer, so you can do a partial override of the pointer.
How do you smash that byte exactly?
So I have it in slides here. Let me actually send you the link to the slides, because I think it'll be useful for you to be able to navigate those. Let me get the slide ID of where that starts.
Thanks.
Yeah, so slide 28 is where the corruption is relevant. And I have this kind of cool visualization of like how it looks with the overlap and how you access those with like the UAF pair and the raw socket and stuff.
What's the UAF pair? Okay, I see. UDP tagged packet. So tagged packet is what we call the tagged packet, right? Just a known value.
Basically.
Okay. So sock raw, that's just opening. What's sock raw?
It's the raw socket that you triggered the double free on.
Oh, is that actually allocated, the purple thing?
Yeah. Essentially, like the main thing is when you trigger the double free on the UAF pair, you can get a triple overlap, basically, where you can have the raw socket and both of the sockets in the UAF pair that all point to the same mbuff. So that's kind of the basis for how they exploit it.
Attempt to reclaim on the UAF pair and get it allocated in the raw socket. Both mbuffs still floating. Also, so you tag packet, you free the UDP packet, shift fragment. Oh, so shift fragment packet is like a fragmented packet, basically.
Yeah, so let me go to the annotation really quick. Send shifted fragment, basically, it sends a hop by hop header, and then a really big but empty routing header, and then it sets up a fragment header like 232 bytes into the buffer. Whereas like the normal send fragment function, it's like a hop by hop, then an immediate fragment header, only 8 bytes in. And the reasoning for that is the reason he shifts, like sets the fragment header so deep into the buffer is it's a little bit complicated because it gets into the intricacies of the IP6 get prev header function that gets abused. Let me go to it really quick. Was it in get there it is. Sorry, get prev header. it does this thing where it does a while loop and it'll keep going until the length overtakes the offset. But when you send that shifted fragment, it sets the offset to be really large so that this can never actually run. So instead of writing into the previous header, it actually writes into the current header. And that's where the overlap happens with the file pointers. And then in frag 6, IP6 get create header, this is where the actual 1 byte write happens. I put some debug logs in there.
Okay, so the shifted fragments are meant to trigger the write.
Exactly. So the shifted fragment gets sent in. They peek the packet identifier to construct more packets, because the shifted fragment, it has that more frags field set to true. So it's not a final packet. So they peek the identifier to construct further packets later on. They then free the mbuff again, and then put the file
How do
pointers
you
in there.
peek the identifier of the fragment?
So this is actually kind of interesting. This is why they have the UAF pair and the raw socket. They use the raw socket to send the headers, but then normally if you read on a raw socket, it's going to interpret those headers. But because they have it sharing with a UDP socket, they can just read on the UDP socket to get the raw data of the headers. And they use the resv from with the peak flag so that it it gives you the data, but it doesn't pop it out of the queue.
I'm confused. Like, what does the are the UAF pair things?
Those are UDP sockets.
Yeah, I'm a little confused at what stage the overlap, like the UAF pairs, are at this point.
So basically, just like what we did on our streams, he triggers a double free in order to get 2 different sockets, UDP sockets, to point to the same mbuff, right? And he checks that by checking the tags and seeing if they don't match up.
Oh, I was confused about your visualization. So basically, on the left is the description, and on the right is the content.
Exactly.
Oh, okay, that makes more sense. So it's UDP tagged packets. Then you free those 2. Then you reallocate the shifted fragment.
Yep. And
but then I still don't understand how you can peek inside the shifted fragment.
So once you have the pair of sockets that both point to the same mbuff, what you can then do is by freeing one of them, like popping one of them out and then allocating again into the raw socket, that's where you can get a third overlap, because that pointer gets released to the allocator and then that other socket can take that too. So now you have the 2 pairs and the third thing. Like, in theory, you can have an infinite number of things that share the same mbuff if you just keep popping and reallocating. Does that make sense?
I see. Yeah, kinda. Just not quite sure from the image you drew how that's gonna look in practice, but I guess so. Actually, if you open up a socket, something gets allocated into the mbuff, or not?
It's not opening the socket. The socket gets opened preemptively at the top of the function. But they spray into the socket so that pointer gets claimed again. Right? So with the double free, you can get it claimed twice. If you just use that as a UAF and you free it and reallocate again, you can get a third overlap. And then if you do it again, you could get a fourth, for example, although they just use 3.
Okay, but I don't... Oh, I think... Yo, your visuals are confusing. So
to be fair, they were mostly for me. So
the 3 boxes on the left, which says UAF pair 0, 1, and socket raw, these are all the same buffers,
Technically,
right?
they all point to the same mbuff. Yeah.
Oh,
And that's why all the
okay.
3 write
Now that
boxes
makes
change at the same
sense.
time. That's kind of what I was going for in my head with the visualization.
Well,
I should have made them all
okay.
point to the same box, but when I was like thinking of it in my head,
Yeah,
this made sense. So sorry.
okay. Trying to
No
catch
worries.
up. All right, so I have 2 UAF pair. Okay, so the UAF. Okay, the UAF pair is actually a UDP socket,
Yeah.
right? Okay, so you sent so you oh so if a UDP socket, you send a UDP tagged
Yeah.
packet, and then you only free one of them, so you have one of the packets still in the receiving queue of the other socket.
So yeah, so you free one of them, which then allows the pointer to go
Oh,
back to the allocator so it can be reclaimed by something else. Yeah.
yeah. So you have basically one UAF socket which has a packet in the queue which it thinks is a UDP packet, but you actually reallocate that with a shifted
Yep.
fragment. Okay, then by peeking to the UDP socket, you can read a shifted fragment. How are you able to do that, although it probably doesn't set the correct
Exactly.
fields?
It's
Does
basically a
it not
type
check
confusion.
the fields?
Yeah. It thinks it's a UDP packet when it's really a raw packet. So that's why you're able to read the raw data where you wouldn't be able to on a raw socket.
Does it not check like the header flags anything when you do the peek?
I guess not. I think it mostly only checks the flags if it's like something really sensitive, like a control message. If it's just like the difference between a UDP and a raw message, they don't check for that, no. Because you would never be able to, like,
Okay, so
in a
you
legitimate system, if you didn't have a bug, you'd never be able to send a raw packet, uh, or be able to read a raw packet on a UDP socket, right? So they don't care. They don't check.
Okay. So you can peek and then you can get the identifier. So you're basically reading something from the shifted fragment.
Yep, that ident field in the fragment header that we were setting to like hex 1337 or whatever.
Okay, you're setting it just to a magic number?
Um, in Sersgovi's POC, they use it as a tag. So he sprays a bunch of shifted
Okay.
fragments with like +I, and then figures out which shifted fragment ended up in the overlap. And that's why they read the identifier out, is to figure out which one made it in. That way they can construct more packets that use the same identifier.
Okay. Free mbuff on pair 1. All right. Slide 34 is really yeah, visuals. Anyways, okay, so you receive the UDP packet. Or what do you mean by that?
Sorry, on which slide?
34.
Again, it's just you're popping that mbuff so that it gets put back to the allocator so it can be taken again.
Yeah, but how do you do that? By receiving the
Yeah,
UDP
exactly.
packet?
You just recipe from and don't peek it.
That's a type confusion already. Okay. Shared mbuff is okay. Shared mbuff is floating between stack of file pointers.
Yeah, that's where that SCM writes thing comes into play. So you spray some file descriptors that then internally get turned into file pointers, and they occupy that mbuff.
You spray file pointers. Okay. So far, so good. Send rest of large packet fragments into final fragment triggers override. So then you send another raw fragment which smashes this one byte, which aligns. Where does the when you do that, where does the file pointer point to?
So let me see if I still have it. I have a lot of tabs open. Okay, let me see if it's these. Yeah, this one. So you'll have to look on stream for a sec, but you see how like FD13 has a file pointer at 7C20, and then 14 has it at 7C70, hex 50 bytes apart.
Wait.
Actually, these have to be changed because I was demonstrating something with them on the stream before. Right, okay, there we go. So FD14, it has 7D20, right? So this is where it should point, because the file objects are going to be side by side in memory. So they're always going to be hex 50 bytes apart. But with the overwrite, you smash this 7D20 into 7D06, which ends up making it not point into its own object, but rather point into the like misaligned into the last file object. And at D10, there's this F offset field which you can set from userland by seeking on the file.
Do you always smash it to
Yes.
be 06?
So yeah, basically what happens there is then when you seek on the previous file, you can set what gets used for the file operations on the next file. And then he sets up like a fake function table in user space. And that's where he sets up the kernel payload to get called on the pull function pointer. And then he calls select on that file so that it ends up taking that function pointer and you get code execution.
Okay.
The reason he always does D06 is because he uses a leak stage to find which file descriptors line up on these like addresses. That way, he can always set it up that the overwrite will smash the object properly.
Do you control that byte, like the 06?
You control it with the next header that you put in the fragment for the shifted fragment, I think.
So you can put an arbitrary byte there. Okay.
But yeah, like when I was trying that strategy on FreeBSD, it worked pretty okay if there was one CPU core and like 2 gigs of memory. As soon as you put more than one CPU core, it just failed like multiple times over. I could never get it to work. I think it's because that like triggering that overlap becomes really difficult when you have more than one CPU. I guess because like there's other mbuff shit happening and it's throwing off the like heap grooming that he set up. But yeah, also I don't know if you noticed on slide 42, I have like a little log of some of the things I put into the kernel to like show me what was going on. So you can see like UDP socket 0 and 1, they share the same mbuff at BE00, and then that gets taken again by the function pointer stack and UNP internalize, and then it gets smashed in the IP6 get prev header.
But it's the last byte is 10. Is that intentionally?
Last byte is 10, sir? Oh, that's the C message data. Because with C messages and mbuffs, like the first hex 10 bytes are used for the header, and then everything after that is the data.
Okay, I see. Oh, then smashing. Oh, okay, so this is a run from where it worked. Exactly. Okay, I see. One thing I didn't quite catch yet is why do you need the buffer to be 3 times in the free list and not just twice?
Because you can't spray those control messages that do the file pointer stuff. You can't spray those on the UDP sockets. You have to use a local Unix socket, or it won't work.
True, but shifted fragment. Okay, but couldn't you? Wait, why do you have TCP tagged packets?
Where do you see that?
Slide 18.
Oh, that's for the leak. Yeah, the leak uses TCP packets. Let me just verify that really quick. Trigger. Yeah, so SOX is UDP. Oh yeah, sorry. In the trigger, it uses TCP sockets on the socket pairs. When you're spraying the file descriptors, those are TCP packets.
Okay, that makes more
yeah,
sense.
there's 3 different packets being used in both the leak and corruption. UDP on the loopback, the UAF pair sockets, the socket pairs for spraying the file descriptors are TCP, and then the raw socket for the fragmentable packets and stuff. So yeah, I mean that's how that POC works, and I thought the idea of smashing the file pointers like that was really clever. I like that strategy. So what I wanted to do for my strategy was, I kind of talked about it before, like how I wanted to try it, although I was doing something that didn't really make sense at the time when we were doing it on stream, because I was trying to hit something that wouldn't work. But doing like a race condition. So I think on my slides I started at slide 45. It's a little bit simpler of like a methodology. I go through like overlapping like a UDP packet with the stack of file pointers to try to corrupt it with fake file pointers. Now, obviously, that won't work because, like I said, there's that empty control flag, which you can't control and it will get unset. And there's a check in the SO receive generic function, which will check if that flag is set. And it will only take the routine that uses those file pointers if it is. But what I wanted to try to do was race that so that one thread would enter the code that did the empty control check, get past it, and then the other thread would cause the UAF. You would then smash the stack of file pointers before it gets used, and you win, basically. 62 basically sums up what I want the threads to be responsible for.
62. Oh, is that your failed strategy, or
no? This is the one that I like came up with today that I want to try. The other thing I was trying before that didn't really pan out on the streams was I wanted to try to hit the extended header, but that's not viable because of how mbuffs are used on PS4. So
wait, why do you try to race when you have like this strategy, this Let's Go strategy, or like the flow strategy?
Because, like I said, it's not really stable because you have to rely on using the double free twice. He uses it twice, once for the leak and once for the corrupt.
I don't understand why you need to use it twice. I just went through the slides and I feel like you can just use it
once for the corruption, but you have to do a leak stage to figure out which file descriptor has the file pointers set up on that boundary so that the 06 overwrite works. So that's why the first like 20 slides are all.
Do you actually have so basically the leak stage tells you which of the open file descriptors you have will be the target one, like the one you want to seek on, right?
Yeah, if you take a look at the stream for a sec, just look at like the top of this main function. You can see he leaks FDs, and then he does this check to find out which FD lines up on that hex D0 byte. That's essentially what the leak is used for.
Why do you need that?
Because otherwise, you won't know which file descriptor you were able to get corruption on, and I don't think you can brute force it because you need to spray the one that you know already lines up on the boundary. Or yeah, sorry, you can't spray on the one that lines up on the boundary.
Oh, because you the one you know that lines up, you need to spray by sending in the messages.
So that exponentially increases your points of failure if you have to use both a leak and a trigger like that. Whereas with my race, you should only have to use the double free once, and it might even be more stable than that too, because you won't have to rely on getting that overlap with the fragmentable packet header. You just hit it like you would a normal overlap, just using a race to get around that flag check. So, like, in a way, it's a lot simpler, and there's less moving parts. Even though it is involving two threads, it's simpler still, I think.
I honestly, I'm not quite all right. Let me real quick go onto your plan. So let's do threads. Let's run two threads to abuse the UAV. Start a read FD on the files on the corrupt socket pair. What does it
Sorry,
mean?
say that again.
The thread one, what's that doing on slide 62?
Thread 1 will issue that control message in order to get file pointers converted into file descriptors. Let me cover that really quickly, actually. Where is that function? It's UNP. I think it's in user request. Yeah, so UNP externalize, which is what that read FDs function will do, is it takes a stack of file pointers and it does the reverse. It'll convert them into file descriptors, and how it does that is it writes into the FD table of the process, and it writes the file pointer into those.
Mm-hmm.
So if you can corrupt these file pointers before they make it in there, you essentially have corrupted FDs in your process's FD table, and they point to user space file objects that you can use to get code execution. So my idea is you basically call this routine to like get close to this point, then it sleeps, you smash the mbuff before it reaches this and corrupt it with your own pointers, and then when this thread resumes, it stores your file pointers into the FD table, and then you can just you get code execution basically, because you can just invoke a method on that any of the corrupted file descriptors that you want, actually.
So when you spray the, how do you spray the file pointers? The fake ones?
So I would spray the fake ones using UDP packets.
So regular UDP packets? Okay, will all of the pointers you spray be valid?
Well, on the PS4, since there's no like pan or whatever, like you can execute and access userland memory, I would just fake the files in user space and spray those user pointers in there.
No, I mean in the packet, like in the mbuff, when you send the UDP message, will all of the data that is actually being read be valid, like valid pointers, or will some of it try to read like header parts, which you can't control, is essentially an invalid pointer?
I believe I should be able to control all of the data, but even if I couldn't, you can spray however many FDs you want with that control message. It depends on the length you set for the C message. So you could spray like 128 file descriptors if you wanted to, and then I could just use one that's later on that would be guaranteed to be controlled to be safe.
Well, that's gonna be like part of the race then, right? Because essentially you don't want to, like, assuming the first, let's say, 5 pointers, or let's say 2 pointers, are overlapping with the mbuff header fields, which means if you replace before these are read, then that will always panic.
Oh, you wouldn't.
In case, I mean, if that's even the case.
You wouldn't. The mbuff header or the C message header? Which one?
I don't know how this works, or is that not even an issue?
I don't think it'll be an issue because you should have complete control over the data buffer of the mbuff, which is what's used for those file pointers. So
okay, that makes sense.
So like
Okay, so that could
I think
work.
overall it's a good strategy because the other thing is too, like I said, you can control how many files you pass in there. And by doing that, you control how many times that loop runs, which means you can extend the race window for yourself. Because you don't have to corrupt all of them, you just have to corrupt
Good
one.
point. Good point. But you could corrupt all of them.
Yeah, you could corrupt all of them or one of them.
That would be fine too.
It doesn't matter. As long as you get one of them, you're fine.
And then you can use seek, which will do writes into user space.
Oh, I wouldn't even use seek. I would just like set up a fake file object and call ioctl, and that would call like the function pointer I control in the function table in user space.
Okay. I mean, the strategy does sound pretty good.
Yeah, I think it's pretty promising.
Because then you don't need to worry about like failed races, really. Okay, what do you do if the race fails?
So that is a potential problem. Like if another thing reclaims where those file pointers were and you don't, you will probably blow up the system. Because if it writes anything that's not a valid pointer there, you're fucked.
What if you do reclaim, but like too late? How can you rerun the race?
So like if it uses stale data, I guess.
No, if it uses the legitimate one. So the thing with the mbuffs, like the UDP packets, is they take some time. So even if the thread sends it, doesn't necessarily allocate, I think. I'm not sure about that. So let's assume you do all you want, but the loop was already done by the time it overlaps.
I think you should be safe because you could detect if you were able to get code execution, and if you weren't, you would just run the strategy again. You wouldn't have to do the double free again because you still have the pair you already set up. You would just like rerun that part again, and you should be fine. I think the only way you're really fucked is if you lose the race and something else puts data there that you don't control, which is possible because mbuffs are used quite a bit on the system. Although on the PS4, it might like they're probably used a lot more on FreeBSD than they are on PS4 because FreeBSD has a lot more daemons running and shit than PS4 does. But I mean that's totally a possibility, but there's no getting around that. I mean, the Flows strategy and Slirsgovy's strategy is susceptible to the same problem. So I was actually saying this a little bit before you joined. I think with this strategy, it's either going to be as stable as Slirsgovy's strategy or better. I don't think there's any way it's worse because I have less potential point of failures.
I mean, you can do like heap allocation and heap feng shui to get these things pretty stable. One thing I do want to like go over again is why 3 buffers are needed instead of 2, because I still don't believe you need 3 yet.
So for the corruption stage,
yeah, for the corruption stage, I went through. Okay, let's see the corruption stage. Basically, let's start at slide, I guess, 22.
okay. Yeah. So
So let's assume you have UAV pair 0 and pair 1 with tagged packets.
yep.
Are you at slide 20? Oh, are we going through 24 or 28? I'm
Oh, I
at
can go to
28.
28. That works too. Yeah, I'll go to 28 for the corruption. Yep. Okay.
Okay, let's assume you have UAV pair 0 and pair 1, like a overlapping UDP tag
Yep.
packet. Then on UAV pair 0 socket, you receive that and free the upper socket. So that one goes stale. Same as you do in slide 29. Then on that slot, we want to reallocate the shifted fragment packet, which will be essentially the same picture as in slide 32, but without UAV pair 0. And then you do the peak. You actually need to do it on UAV pair 1 since 0 is already freed. Free mbuff on pair 1. We can do the free on pair 1. And then in slide 35, we don't actually have any more of the UDP sockets, but only the socket raw and the floating thing. And then we send the file pointers. So then in slide 37, it should be just socket raw and the file pointers, but no UDP anymore.
You need the UDP or the UAF pair to send the file pointers, though. You can't send those on a raw socket.
Oh, but they don't need to be on that mbuff allocation. You can send it to any socket. Actually, didn't you say you need
Yeah,
to
you need
send
to overlap them.
You don't need to send them.
You want the
Why do you
pointers
need
to overlap with the sorry, let me just look at it for a second here.
Oh, how do you send the file pointers? It's not like what kind of socket is that? It doesn't matter, or does it?
You have to send it on the AF Unix socket. So
Oh yeah, that makes sense.
that's on the UN array, which is set up with the
All right, so it's a Unix socket, but still, that's so all the way we went here. This is still just one overlap, so you only have the buffers two pointers to the same unbuff, not 3. I think your graphic is just a bit confusing. Because even when your graphic, you only have 2 pointers to the same buffer, not actually 3.
I think you should have 3. It should be on.
No, I think you're just confusing yourself with your visuals. Because if you go through what you've written there, it's logically still just 2 pointers to 1 buffer, not 3.
Both UAF pairs will point to the same mbuff, and the raw socket will point to the same mbuff. That would be 3 references.
No, not at the same time though.
Okay. I think I kind of see what you're saying.
So it's not actually like you can access the same buffer, same mbuff from 3 directions at the same time. You can only do two directions at a time. which is just let's say a normal overlap which we had in our previous tests. So you don't need to trigger the bug like multiple times to get even more pointers to the mbuff. That's not necessary.
Okay. So yeah.
And then,
Sorry, go ahead.
if we take a look at the leak, let's go through the leak. So UDP tag packet, you free one of them floating a TCP. Why do you do a TCP tag packet?
To know which socket pair has the freed mbuff.
Okay, so in slide 18, a UDP packet overlaps with a TCP packet, and which basically contains a TCP packet now. And then what you can do, you can peek on the UDP end to get the socket pair ID. What is that?
Basically, when they spray into the TCP leak pair, they spray the socket identifier as the tag data.
So it's a tag.
Yeah,
It's just
exactly.
a tag, data tag. Okay, so you peek and get a data tag. Now the leak pair ID is known. Okay, and then you receive the UDP packet and reclaim mbuff with file pointers. Okay, so then you have a TCP packet overlapping with a stack of file pointers.
Yeah. And you need that leak pair set up because you're not going to be able to read those file pointers on the UDP packets. Or on the UDP sockets, sorry.
Okay. Triple overlap's actually incorrect. Okay, so then you can do read on leak pair 1 to get a stack of file pointers which can be read. Contents of buffer received on leak pair 1. What is leak pair 1? Is that a UDP? Is that a why do we even have TCP tag packets? Shouldn't that be a AF socket? A Unix socket?
It's a socket pair, which I don't really use that often, but it basically it allows you to get like two sockets that are connected, and that allows you to like write on one end and read on the other. It's kind of like pipes, but for sockets. So that's what the socket pair is, or the leak pair rather.
Okay, how exactly does the leak work? So you have a TCP packet overlapping with a stack of file pointers.
Well, your stack of file pointers is in an mbuff that's pointed to by the UAF pair of UDP packets, as well as the socket pair of the which is the leak pair.
At which one you read to get the actual pointers?
Let me just look at the annotation real quick to make sure I'm correct on this. Right FD. You resv from on the UN array, which is. Why can't I find it now? Oh, here it is. Yeah, you receive you resv from on the Unix TCP socket.
On the TCP socket. So basically what you want to have is you want to overlap a TCP socket with a stack of file port. I'm just curious, can you in theory also overlap? Why can't you like do it the other way around then if you can read that? Oh, do you need to set certain header flags which
Certain
get lost
header flags,
otherwise?
exactly.
Okay.
Yeah.
And then you read and you receive the stack of file pointers, and which frees the thing. Okay, so two things which I think you messed up a little with your presentation is A, you never need to have a triple overlap. It's always just a regular double
Like 2 references, not 3.
use thing.
Yeah.
2 references, not 3. And the second thing is you don't necessarily even need to trigger the bug twice. It is enough if you have one single overlap, which is 2 references to one mbuff during the entire exploit. You never need to actually trigger that thing twice, because you can use the same overlap from the leak later in the corruption if you just like keep reallocating the same overlap.
That is true. In Sliersgovy's POC, he does trigger the double free twice, but I think you're right. I think you could do it with one. Thinking on it.
You don't need. And then about the peak, which gets you the buffer ident, you also don't necessarily need the peak. I'm not sure. Can we get that on PS4?
I remember when we were trying in the browser, we were trying recipe from, and it wasn't working properly. But it might have, like, I need to play around to see how the peaking works. There's a few points in this, in his POC, where you could absolutely replace, like, not peak, just pop it out entirely, and it would work. It just might not be as reliable because you want to control exactly when you pop out if you can. That way, there's less chance of noise and shit happening in between, right?
Oh, we can totally control. Like, see slide 23 and 24.
Yeah.
Right? So you peak, and the next slide you pop, which is, of course, you want to pop the one that you know that is the target one because you peaked before, right?
Yeah. I feel like there's one case,
But
though, where you do peak quite early compared to when you actually pop it out, which would be problematic from a reliability standpoint if you just popped it at that point. I'm trying to remember exactly where that would have been.
so basically, you can replace the peaking, which is first you peek into all packets and look which one is the target, and then you pop just the target, by just always popping. And every time you pop, you do the spray, and then you have the chance of either it was the target and it hopefully worked, or it was not the target and it didn't do anything. So basically, every time you pop, you just spray and assume it worked, and try to. Oh, is that gonna be problematic? Trying to receive pre-mbuff. Where's the peak? Oh, because when you peak, when you pop it, it will also give you the ID. So once you actually pop it, you will know whether it was a target or not, which is whether you should recollect your spray or not. So basically, what you can do if you have the packet in the queue, you just pop it and then spray, and like thinking it will be the case, and then you actually see what you read, because when you read it back you get also the ID. And if it's the wrong ID, then if it's the right ID, then you know, okay, everything is correct. And if it's the wrong ID, the stack of file pointers you just sprayed, you can just like free it again to not waste memory, and then just retry until you did that and receive the correct ID.
Yeah, that's good to keep in mind, I think, if like we needed to fall back on this strategy if my strategy doesn't work. That could be an optimization point. Yeah. As well as
it's actually going to be slower, but it will not require the peak and shouldn't really impact stability.
I kind of hope that I can still use the peak on the PS4, but I do remember we were having problems with it in the browser.
Yeah, it's maybe because we fucked
It's
up
possible,
something.
yeah.
But so if you get it working, it'd be great. If not, we can still do without.
Yeah. But yeah, I mean, I kind of like how my strategy's looking. I don't see anything that would fuck it up, but I guess the only way I'll know for sure is if I like go to implement it. I was kind of telling stream.
So
and I think you caught this on the tail end because I was talking about test-driven development, but I'm probably going to use a VM.
Yeah, that's literally the time. Like when you mentioned Teamstar, that's literally the time when I like turn on the stream.
That's awesome. But yeah, I mean, I'm probably going to try to get it to work on the FreeBSD VM and then port it over afterward, just because like a reboot on a FreeBSD VM takes like 20 seconds, whereas a PS4 takes forever. And it's just so much quicker to test with, and I can hack the kernel too to like give me some helpful debugging information where I can't easily do that on the PS4 without doing hooking and all that shit. I did want to pull something in a chat. IRC, there's a per core mbuff cache. So I believe the per core caching is a PS4 thing. I'm not 100% certain on that. I did try looking at like doing some reversing of the VM subsystem. I did a little bit of that on stream, but it was hard to confirm. There's so many layers of indirection when it comes to that. But I'm pretty sure like that per core shit is a PS4 thing. I don't think it's on like stock BSD.
Might be problematic with your exploit though. One thing I did want to say, you didn't tweet about the stream, did you?
I did on the Day Zero account. I forgot to retweet it on my main account.
Maybe I should follow.
Usually I retweet it, but I forgot to.
Maybe I should follow that.
With regards to one core being an issue, I don't think it will be, because even if you do like the multi-threading, especially with the way core pinning works on the PS4, chances are your thread is still going to run on the same core, or it'll run on a core that shares the same cache. Because I'm not sure if the memory stuff is a per core cache or if it's a per core cluster cache. Because for those who don't know the PS4's like hardware layout, they basically have 8 CPUs that are shared between 2 clusters of 4, which have their own like L2 cache and whatnot. So if it's per cluster, which would make more sense because that would fit in with like the L level caches, it would be like no issue at all because the browser is always going to run on the same 2 CPUs, and any threads you use on it are going to run on those CPUs. So it should be fine, I think, in that case.
I think one thing to keep in mind about the caches is it will affect maybe timing at most, but not like the actual data. Like even if it runs on different things, cache will, due to cache coherency, which I hope is implemented properly, even if it's not in the cache, it will still fetch the correct data. It's not like if it's not in the cache, it will get the wrong data or something.
Yeah. So, yeah, I mean, that's the overall exploit strategy. If I was saying earlier, I might do like a video afterwards or something. If I do, I will clean up the slides because I could totally see how, like, the way you were interpreting it, I was like, yeah, maybe I could have done a better job. Like I said, I mostly did these slides for me when I was trying to piece it together.
Yeah, but you see, you kind of also just confused yourself
a little bit,
the
yeah.
thing.
But yeah, like overall, I think it's a cool strategy, and I should be able to make it work. The hardest thing will probably just be narrowing down the timings. On the FreeBSD VM, that I don't think that'll be like too bad because I can do those debug prints and I can print exactly when things are happening. Porting to PS4, messing with the timings could get annoying though, but I mean, like I said, I think I can extend the window, and the window's already pretty large, so I think it'll be fine.
The important thing that you need to make sure is, assuming you failed the race and it didn't blow up your system, to recover and rerun. If you can do that, then you just try a bunch of times and eventually it might succeed. But like the recover and rerun, that's the important part.
Yeah. The other thing we have to keep in mind too is remember sometimes how when we left the browser or whatever, when it went to close the socket, the system would blow up with that SB internal flush thing or whatever. This is
Yeah.
one thing that Slirsgovy does in his kernel payload. If you take a look at the for loop here, he basically writes into the FD table where the sockets are located, and he zeroes out the send and receive socket buffer shit so that that doesn't happen. So that might be something that we'll have to keep in mind that we might have to do in our like kernel ROP chain or whatever post
Yeah,
exploitation.
we will do the cleanup later. I was actually looking into some XNU socket stuff because also worked on an exploit cleanup actually on the iOS 14 exploit, and that coincidentally also involved sockets. So there's basically um, in that case there was a pointer that you can zero, which if it's not allocated, it will to prevent from freeing. But for the PS4, we probably want to make sure not to clean all of them, because if they're allocated and you zero it and it doesn't get freed, then it's essentially memory leak, which we also kind of want to avoid. Like, I can see that for Slayer's Govy, he just like does a quick and dirty hack. So I'm actually not sure if it's the case or not. But what I can imagine is that it will just zero all of them so it doesn't panic, but that will leak memory, which we want to avoid in the final thing.
Yeah, yeah, I'd agree. This is one thing I hadn't really looked at with the detaching the bucket from the zone M buff. That's a bit strange, but I'm not totally sure what's going on there. But yeah, that could be looked at later. Like you said, the cleanup is that's post exploitation, which we're not at yet. And yeah, regarding the iOS thing, I think I saw that on Twitter today. Actually, you were saying like people kept badgering you about it, so you just dropped it or whatever.
Oh, it's actually
Oh,
just a
okay.
meme. Basically, last time we were trying to fake leaking the thing, but which kind of got interpreted wrong because like some of the members didn't know about that. So this time I just like in quotes leaked. So we released some of the code which we use for kernel read and write. So this is what you see now.
Okay. Oh yeah, that's with Seguza's efforts to standardize the primitives, right, or whatever.
Actually, not. The day dates back to some of the exploits we wrote back in iOS 9. And then he came up with like some methods, and I basically reused the same function for a similar purpose. And this is why I decided to credit him.
Oh, okay.
Basically, the set context thing is what you're using. It's a way of setting 64-bit value in kernel space. And if you know the address, like the memory address of it, you can write 64 bytes from user space there using like a function call. And I like chain that up to dereference pointers a couple of times, which I used for the actual read and write primitives.
Dude, iOS is so like fun and fascinating to look at when you look at primitives and what you can do, especially with like task ports and all that shit. I wish I could like justify wanting to
Yeah,
look
they
into
get
iOS.
narrowed down
Yeah.
a lot.
I wish I could
Yeah,
justify like looking
I remember
into it,
one
but it's
time.
like I'm so far behind the game on Apple that I would spend probably like a year just trying to play catch up and fuck that.
Oh, if you're interested, we can do some iOS
It could
hacking.
be fun. Like it's always been kind of interesting to me. It's just one of those things where it's daunting looking at how much I'd have to catch up on to like be able to like catch up.
Oh, we can. I have a target in mind. So if you want to do something at some point, I can buy a certain device. I can tell you more about it later, and then we can look at an older device. and hack that, which is actually a really fun
Yeah,
experience.
dude, that sounds like fun. I'd be down for that.
Okay, yeah.
There was one other thing I wanted to bring up to you that I was talking with Stream a little bit about earlier, but when I was looking around at mbuff stuff and how I could potentially, like, I was thinking I'd want to go with a race, but I didn't know yet if I wanted to use the same strategy of hitting the file pointers. I was thinking of maybe trying to induce a heap overflow in the mbuff zone, by like using a C message header or something, like smashing a length. Unfortunately, everywhere I looked, where a length was used, it was cached like on a local variable, and then it was checked. So you couldn't really race it because it was never used again outside of where it was cached, and like you couldn't corrupt it post validation basically. Um, but like when I was looking around at how to do that, I discovered like rediscovered CTurt's like really old write up on a send message heap overflow in FreeBSD, and he basically uses it to smash the metadata of an adjacent zone in order to get code execution on UMAZ freeze. And I was like, damn, I really want to like reuse this strategy because it's really cool and like really stable. But yeah, I couldn't find anywhere that I could induce a heap overflow, so I was kind of sad. But it's just kind of funny to see how that could work.
Could we ever trigger that UMA free thing?
Um, Yeah, I think that like all you would have to do was get something freed from that adjacent zone, and it's game over. I think because it would follow that pointer.
Okay.
Yeah, like I really like because that strategy would probably be even more stable than the file stuff. Because if you just fill up a zone like an mbuff zone with your own shit and you overflow in it, you should be fine. Like you could heap room in a way that you would never smash anything super important that would blow up the system. But yeah, like I said, couldn't find a vector to do it. But oh well.
I feel like we need to step up your game on being confident about exploit strategies. I mean, I've seen and written exploits which you think, well, that shit can never work, and it ended up pretty reliable. I think in that regard, Zigusa is like a dark magician. He exploited some like super hard race condition, which I didn't think can be like that reliable, but he turned it like almost 100%. I still haven't figured out
Wait,
how he
who
did
was this?
that,
Sorry, Ian
even
here.
though I reversed this exploit.
Oh,
No,
Seguza.
Zigusa.
I thought you were talking about that one byte out of bounds right that Project Zero did a write up on like last year or whatever.
Oh, that was pretty cool, although I didn't really look into that. But I was actually talking about like the light speed bug, which Zigusa managed to exploit like super reliable the second time it got introduced, because Apple actually patched it and then
I
reintroduced the
think I
same
remember
thing.
that vaguely.
Um, and then I actually reversed his exploit and re-implemented it. But I never got the same reliability as him. So I'm really curious what he did, and I'm still waiting for the write-up.
Yeah, dude. Heap grooming is kind of a dark art that I haven't really mastered that much because I haven't had to. The bugs that I've exploited so far, I've been able to get away without doing like I do some heap manipulation, but not a ton. Like I don't do a bunch of stuff with pages and trying to get pages aligned and shit. Um, it's something I like want to get better with for sure. Um,
Yeah, I can help you with
yeah,
that.
cool.
I suggest you try your racing thing, and in case that fails and we switch to the other thing, I will try to join in if I
Okay,
manage.
that sounds good. Um, yeah, I mean, with doing my strategy, I'll probably be doing a few streams, like throughout the weekend, possibly. I don't want to say for sure because the weekend is a little bit weird for me, but yeah, I probably will do a few like later streams on weekends, but yeah, like I don't know if you'll be able to join me because I imagine you're probably busy on weekends too. But
Just make sure to tweet. I did follow the Day Zero account, and if I see the tweet, I will try to hop in
okay,
maybe.
awesome, sounds good. We'll definitely try to sync up again next week at some point. Hopefully by then I'll have my strategy like implemented and it'll just be a matter of porting it to the PS4. So all right. I think I'm probably gonna call the stream in a few minutes here though. It is 4:30 in the morning my time, so we're pushing it pretty late. Checkra for Windows, somebody says. I haven't followed Checkra in a while. I know there was work to be, like, people were trying to work on porting the USB stack or whatever to make Checkra work on Windows, but I don't know if it ever got finished. Because I know it was a lot of work, so. But yeah, I mean, what else is there? Thank you for doing what you do. I play around with IDA, but not to that level of familiarity. Yeah, I mean, to be fair, exploit dev is generally pretty detached from reverse engineering, unless you're looking at like Windows or maybe the closed source iOS stuff. Like you mostly just use reversing as a means to an end in exploitation. You're not doing obfuscation reversing or anything like that. So it's mainly just using it to try to get like the lower level type information or sizes and stuff. So yeah, the reverse engineering you can go a bit lighter on if you wanted to go into exploit dev. I don't care about PS4 jailbreak. Just came here to support these dedicated, awesome devs and researchers. Well, thank you, man. I guess a final thing I'll say, Teamstar, is somebody asked me earlier, so I'll relay the question. Are you interested in all in PS5? Do you think you'll ever like do research in it?
So I see where the question is going. Is, hey, Teamstar, are you gonna jailbreak my PS5?
Jailbreak ETA when?
I mean, the thing is with Sony consoles. So I did actually buy a second PS4 earlier last year because I wanted to try the Linux thing. It was like, if I'm gonna do that for the PS5, I will probably need to have like 2 consoles. So it's, for me, do I want to hack it? If yes, buy 2. Because I also, if I have a PS5, I want to play with it, which I can't do with the console. If
I know the feeling.
Because you have to buy it and let's keep it at the lowest firmware, and then once a newer one releases, you can't log into the PlayStation Network. For example, when I bought the Switch back in the days, it was a different story because I didn't want to play online anyway, and offline you can just like play and have as much fun. But like for PlayStation, you pretty much want to go online, so it's gonna be like buy 2 of them.
Yeah, I have 3 PS4s right now.
I'm not really sure. I'm not sure. And the thing is, if I want to be doing PS5 stuff at some point, I probably should get a PS5 as quick as possible to have like lowest firmwares and thing. Like even if someone else releases something, I want to be on a low firmware. Yeah, I'm not quite sure because I also recently thought about just getting a PC to do some game, because I wouldn't even know what to play on PS5, honestly.
Yeah. PS5s are hard to get here. I probably, if I tried really hard, like, stayed up and ran scripts or something, I probably could get one, but I just don't care that much. Part of why I brought it up though is it sounds like the PS5 from a security standpoint is a lot more interesting than the PS4. For example, it has execute only memory. So that would make trying to do ROPing and stuff very interesting. I was actually like theorizing a little bit with the stream before on how like you might be able to get around that.
Is that x86
Yeah.
still?
The RDNA2 chip or whatever they have in PS5, it has execute only memory, which is interesting because I don't think there's any AMD chips on the consumer market, like in desktop or something, that have that, as far as I know. So it makes sense because the consoles work, like Sony works with AMD internally, so they get some of the stuff early. But yeah, so they have like execute only memory. They're gonna have SMAP, SMEP. It's running a newer FreeBSD. I think it's probably running FreeBSD 11, judging by the time frame. So it could be interesting to research from a security standpoint. The problem is, like I was talking about it a bit earlier, is like the end game for exploiting a console is like really depressing to me now, because like any homebrew you would write, you could just run on a PC and it'll do it better. Like, so
I can see that.
Yeah,
Yeah.
so I'm a little bit in the downs about like homebrew and post exploitation, but at least from a security standpoint, I think PS5 would be fun. So
From security, it would be fun. I remember when I back in the days had got the PS4 and then played with QWERTY. He would just go through all the pain to cheat in
yeah,
GTA 5. That was
yeah,
so
he
much
was.
fun.
That's how he got caught, or how his exploit got burned. See, he had the console. Yeah, he had the
Really?
console online for playing GTA, and the kernel panicked.
Oh, I know. I've done that with
Oh,
them. I
okay,
know.
yeah. I didn't know if you knew that
But
the crash log leaked back to Sony.
I didn't know. But yeah, I can see
Um,
that.
it was kind of funny because that was the BPF bug in 4.55 that he was exploiting, and the crash report got back to Sony, but they couldn't figure out what the bug was, so they just stripped out the piece of code that triggered the code execution. But like that didn't really work because there was other ways to do it. So
Okay, okay. That's
yeah,
fun.
that's the Sony way of doing things. Whenever there's a problem, they just remove it. Because at least until like 6.0 or whatever, they had a lot of attack surface that they exposed for absolutely no reason. Like they didn't even use it. They just like allowed people to use it.
Yeah, well, that means they shouldn't have had it in the
Exactly.
first
Yeah.
place.
So they're just like, oh, screw you. You're gonna exploit that. Okay, attack surface is gone. And then that's where they put all their efforts now, is like reducing the attack surface as much as possible. But
Which makes
yeah, it's fair
sense.
from their point of view. I don't really like it from an attacker standpoint because it feels lazy, but from their point of view, it makes perfect sense, and it's efficient, I guess. Um, yeah,
The other thing. Oh, do you want
no,
to
no,
go
you can
off?
go ahead. I was gonna say something else.
Oh, I see. The other thing is that I don't not sure how many people are aware, but I've never actually actively looked into bugs. So I've always just like exploited public bugs. So I don't really feel like looking for bugs. This is the other thing. So if I'm gonna do some PS5 stuff, it will probably just me waiting until somebody drops something, which I may try to port. So when I got the PS4, I tried to look into WebKit and I like found lots of commits which fixed bugs, and I'm sure there were some potential bugs which were fixed with certain commits which I looked at, but I couldn't just figure out what the issue was, even though I had the before code and after code. I was like, I have no idea what any
WebKit
of
is
this means.
so hard to root
So
cause. It is so fucking hard.
yeah.
Um, yeah, I mean, it's funny. I feel like a lot of people are in that boat. There's a lot of people that like doing exploit dev, but they hate the vuln research angle. It's like it's almost like two different. It is two entirely different skill sets. Like vuln research involves like code review and like a lot of determination and wanting to just keep digging, whereas exploit dev, I mean, it kind of does too, but it's more trial and error, I guess. Um,
There's the other side too, though, because I've also met people who are really into finding these bugs, um, but some of them are like less interested in exploiting them. It's more of for them, it's more of just trigger and good
yeah,
to go, which is kind of what the industry wants today, anyway.
yeah, they want you to find an issue, show that it's an issue, and fix it. They don't care if you can like do cool shit with it. Generally, um, yeah, I've seen a lot of write ups like that. They go like, "Oh, I found this bug. I managed to trigger a crash, and that's the end. Thanks." Like they have no interest in trying to take it to like code execution or whatever. But that's fair. It's kind of like I don't think very many people have a strong interest in both, like vuln research and exploit dev. It's usually one or the other, I think. From what I've seen.
Agreed.
Um, yeah, the thing I wanted to touch on with chat was like a lot of people are bringing up the de novo stuff with PS5. From what I understand, that's been in place in PS4 too. That's not really new, and I mean it's kind of overkill anyway. Like anti cheat doesn't make sense for the consoles because it's going to be protected by the console security. you're never gonna have like rampant cheating on the PS4 or anything, because unless Samu gets broken, which that's a different matter, I guess. But for the most part, you're not gonna have rampant cheating, because you would have to have a 0 day in order to cheat, and if you have a 0 day, you're not going to be sharing it with a lot of people to cheat with, or else it's going to get burned pretty fast. So usually, like, maybe a handful of people could cheat at a point in time on a console. So it seems like kind of overkill to do anti-cheat stuff, but whatever floats the boat. But yeah, I think we'll cut it off here. Did you have any final thoughts you wanted to put out there before we cut it off?
No, I think
Okay,
I'm good.
cool. Like I said, we'll try to sync up at some point next week. We'll we'll try to figure out like when works, and we'll see. I don't think we'll do like a scheduled thing like days beforehand, but we'll see like when works for you, and or if you just want to jump in when you see the tweet, like you were saying. So
Yeah, I guess if you want to work on your race strategy, then just go ahead and do the streams. If I do follow the Day Zero account now, so I may jump in. But you can do like, I'm fine if you do a couple of streams
all
without
right,
me.
yeah, cool. Like you're always welcome to jump in. I'll jump in Discord anytime, so feel free. All
Okay,
right,
cool.
so we'll cut it off there. Thank you for everyone who tuned in. This exploit strategy looks promising, so that's where my next few days will be. Follow us on Twitter, or check out our Discord, or both. That's where I put up the announcements for when I do the streams. I'll put it on the starting soon screen, and then I'll put those announcements out. So they're kind of ephemeral. You have to, be in those channels already to see them if you want to jump in the stream right away. So go ahead and follow those channels. We also have the weekly podcasts, which are happening on Mondays, which I actually have to do some of my notes for this weekend. So this weekend's going to be a fun juggling act. But anyway, for anybody that's interested in that, feel free to tune in. Other than that, we'll be back on another stream at some point, and I'll see you guys then.